Hi, today we're going to talk about the parachute activity. It's the beginner's parachute STEM activity. STEM stands for science, technology, engineering, and math. This is where students will learn a lot of different subjects in a lot of different ways all at once. This can be really fun. The engineering design process. This is a 6-step process to help guide students complete their mission. The process is all in order for a reason. Allow the process to guide you through to the end of your challenge. The first question is ask, what is the problem? How would I make a parachute? What does a parachute do? What does a parachute look like? How can I make my own design of a parachute? Now let me close my eyes and imagine a parachute landing on Mars. What color is my parachute? What shape is my parachute? What does it look like? How is it made? How is it totally different from anything else? Now, we're going to take our ideas and we're going to draw them on paper. It doesn't matter how perfect you think it looks. It matters about the experience and the experiment going correctly. So let's put all of our creative thoughts down. We'll also always give praise to others and their ideas, because you never know. You may need them in the end. Now, teachers, this is a good time to assess students by observing. We want to understand, what do they know about a parachute? What does a parachute look like? What is its function? And we want to see if they participated in at least giving their ideas on how to change the parachute. Sometimes there can only be one person in each group per job. Sometimes only one person is the model drawer. Now we're going to make our model. We're going to look at our design and we're going to use our constraints or materials to build our model. We're going to do the best we can. And then we're going to do the experiment. This is when we get to try it out and see if our hard work paid off. Usually it does. Let's try it. Okay, here goes experiment 1. Alright, this one didn't do too bad. The parachute landed on Mars, but it tipped over a little bit. We need to make sure the cargo lands straight up and down and doesn't spill over. Now we're using cloth, twine, a tin bucket, and pennies. What can we use to ensure that the parachute lands in a straight line and does not tip over? Is the parachute shape the right size? Do we have it tied around the tin bucket correctly? Maybe the pennies could be used as weights to help the parachute fall straight down. You don't have to use all your materials at once when you get your first design going. You may need them later on in the experiment to change your ideas. Teachers, here is a good time to make all creative ideas and solutions to be heard. This builds positive social skills, positive self-esteem, and gives us an assessment to look at the student's ability. Were they able to come up with the answer to the challenge? Did they understand the problem? Do they know what a parachute was? Could they help modify? Did the design of the parachute make any difference in the landing? Did the materials you choose in the parachute help the cargo? Did perhaps the kind of parachute material you used made a difference? If you used the tissue paper, the parachute might have broke. If you used the cloth paper, it might have landed softly. How many pennies did you need to use to land the cargo upright? That's what you should find out on your second experiment. An upright, safe cargo landing on Mars. Way to go, job. Mission accomplished. Now, what we'd have to do after that is have to record the students in their science journal, STEM journal, and we wanted them to explain what the activity challenge was about. How do I make a parachute and land on Mars? What modifications will I make? How does a parachute work? Kind of test their schema or background knowledge. Let's find out the ideas they liked. Let's keep using those. Discussing beforehand and brainstorming. Labeling materials. Working together as a team. Now we have a mission accomplished certificate to give at the end. These really mean a lot to the students, and they can put it in their journals and take it home and show it to their parents. Now, we have a new way to grade things. They're called rubrics. Yes, I know you've heard of rubrics before, so you obviously know how to make these. One I have suggested is, can explain the problem or challenge in the activity. He understands the big idea and the standards. He can give an ideas about the challenge. So he is thinking about how to change the problem and do the solution. Does he know that there is a problem to be solved? Or does he just think, okay, parachute on Mars, no problem. Does he understand the problem is how to make the parachute and land on Mars? Or does he not understand that the challenge is a problem to solve? It's just an idea. It's a story. We're going to hear about it. Thank you for listening to my engineered design process explanation. I hope this helps you out.